Hello everyone and welcome to our presentation. We are students from FOCS 1434E and today we are going to demonstrate a practical real-world application of a foundational algebraic concept, Cramer's rule. Moving on to our project topic, we decided to analyze a scenario that is highly relevant to campus life, the sales of academic books at a university bookstore. The beginning of a semester is always a peak period for bookstore transactions. We wanted to explore how linear algebra can be utilized to help a bookstore manager break down and analyze their sales data efficiently. To give you an overview of the problem scenario, at the start of the semester, the university bookstore sells three main categories of academic books. To construct our mathematical system, we have defined these categories using three variables. Let X represent the number of mathematics books sold, let Y represent the number of programming books sold, and let Z represent the number of business books sold. The bookstore manager wants to determine the number of books sold, the total revenue generated, and the total reward points awarded to customer. Cramer's rule is used to determine the number of books sold in each category.
To guide our research, we established three primary purposes. First, we wanted to bridge theory and practice by applying Cramer's rules to a practical business problem. Specifically, our second goal is to determine the exact sales volume across three distinct categories, which is mathematics, programming, and business textbook. Ultimately, this demonstrates how abstract system of linear equation serve as highly practical tools in model retail management.
Step 1, we need to let X equals to mathematics books sold, Y equals to programming books sold, and Z equals to business books sold. Step 2, we need to form system linear of equation from the situation given. Then we will get X plus Y plus Z equals to 250, 40X plus 50Y plus 60Z equals to 12700, and 2x plus 4y plus 5z equals to 1000. For step 3, we need to express the linear equation into matrix form. Step 4, we need to calculate the determinant of the coefficient matrix A. Step 5, we need to construct matrices which is AX, AY, and AZ by replacing the corresponding columns of A. Step 6, calculate the determinant AX, determinant AY, and determinant of AZ. And then we need to apply the Cramer's rule to find the value of X, Y, and Z. Next, I will use Cramer's rule to find the value of X, Y, and Z. First, we will find the value of determinant of matrix A, which we get the value equals to -10. After that, we change the first column with the constant to find the value of determinant of AX, which gives us the answer equals to -800. Then we apply Cramer's rule, which is determinant of AX divide with determinant of A, and we will get the value is 80, which is the value of X. After that, we will find the value of determinant AY by changing the second column with a constant, which we will get the answer equals to -700. So we apply Cramer's rule to find the value of Y, which is determinant of AY divide with determinant of A, and we will get the answer equals to 70. Lastly, we will find the determinant of AZ by changing the last column with the constant, which we will get the answer equal to -1000. Then we use Cramer's rule, which is A determinant of AZ divide with determinant of A, and we will get the answer equals to 100.
For the result, based from our solution, X is mathematics book and The total mathematics books sold is 80, and Y is programming book, and the total programming books sold is 70. And lastly, business book, which is Z. The total business book sold is 100. For discussion, this problem was solved using Cramer'S rule, a method used to solve system of linear equation with the same number of equation and unknown. The determinant of the coefficient matrix was calculated as t equal to -10. C is not equal to 0. The system has a unique solution. The obtained solution were verified by substitute them into the original equation, and all given totals were satisfied exactly. Therefore, Cramer's rule is an effective method for solving real-life business problems involving bookstore sales data.
By using Cramer's rule, we found the exact number of books sold this semester. The math shows that the bookstore sold 80 mathematics books, 70 programming books, and 100 business books. These numbers add up perfectly to match our records of 250 total books sold, 12,700 ringgit in total sales, and 940 reward points given out. This study shows how useful math can be for running a store instead of guessing. The manager can use simple sales data to see exactly what is selling. This helps the store keep the right amount of stock, use shelf space better, and make smarter business choices for next semester.